In this lesson, we're going to look at how to solve a radical equation. And a radical equation is one where the variable occurs in a square root, a cube root, or a higher root. And a very basic example of that would be the square root of x equals 7. So the basic step would be, well, I want to get 1x, so why don't I square both sides? So if I take the square root of x, square it, and square the right side of the equation as well, the square root of x times the square root of x gives us x by definition equals 49. So square both sides and solve for x. Now, before we proceed, we need to look at why that might not always be the best thing to do, or why we might need to do extra steps. So here's a basic example. If t equals 4, if I follow the same steps that I did in this earlier example, if I square both sides, I'll get t squared equals 16. And so if I have t squared equals 16 and I want to solve for t, I'm going to take the square root of both sides. So t equals plus or minus 4 because 16 has two roots, a positive one and a negative one. So we're getting two solutions here, but only positive 4 is a solution to the original equation. So that leads us to a rule, and this is only going to happen when we have even exponents, because when we have odd exponents, if we have a root of an odd number, we'll have an odd original number, and the sign will always be the same. But with even roots in even powers, when we take the square root, we can have a positive or a negative solution. So when we raise both sides of the equation to an even power, so if we're doing that as one of the steps in solving our equation, we need to check the proposed solutions, because sometimes there'll be more than one solution, in the original equation. So we have to go back to the original equation and check each of the answers that we get. So let's look at a couple of examples. So this first one is a radical equation. I have the square root of x plus 10 equals x minus 2. The first step in all of these equations is to put the radical piece by itself on one side of the equal sign. So you're isolating the radical. In this example, it already is. Okay, but isolate the radical is the first step. Okay, then we will square both sides of the equation. And then we'll solve for x. And if necessary, we will repeat. So let's take a look at this example. So if I square the left side, so if I have the square root of x plus 10, and I square it, and x minus 2, and I square it, so I'm squaring both sides of the equation. When I square a root, I end up with whatever's under that radical sign. So on the left, I have x plus 10. When I'm squaring x minus 2, remember that's x minus 2 times x minus 2, and I need to use the distributive property, so I'll get x squared minus 4x plus 4 when I square that. So now let's let's make that equal to 0, because I can see that I've got a quadratic here, and recall when we're solving a quadratic, we want all of the variables and numbers to be on one side of the equal sign, and we want 0 on the other side. So if we do that, we're going to have x squared minus 5x minus 6 equals 0. And if you're not sure how I got that step, press pause and try it yourself and see if you get the same. So now I'm going to look at the left side. I'm going to factor it. I need two numbers that multiply to give me negative 6 and add to give me negative 5. So I'll have x minus 6 and x plus 1 equals 0. And recall, if these two factors multiply to give me 0, then either x minus 6 equals 0 or x plus 1 equals 0, which gives us x equals 6 or x equals negative 1 as two proposed solutions. Okay, so before we decide whether they are solutions or not, we need to check those answers in the original equation. So let's start with x equals 6. So if I plug that into the original equation, I get the square root of 6 plus 10 equals 6 minus 2. If I get the square root of 16 equals 4, that's correct. So that means that 6 is a solution to the original. So now let's try the same with negative 1. The square root of negative 1 plus 10 equals negative 1 minus 2. So negative 1 plus 10 is 9. The square root of 9 equals negative 3. That's not true. So that means that negative 1 is called an extraneous solution. So with the method that we used, sometimes we get more than one solution that actually works with our original equation, and this is an example of that. We call it an extraneous solution, or not part of the solution. So our solution is 6. And we can put it in set notation saying that the solution set is 6. Okay. So let's take a look of what happens when there are two radicals in our equation. And we have an example here. The steps are the same. We're going to isolate the radical first. So we will, what we'll do is add the square root of x plus 4 to both sides of the equal sign, so that we have that square root of 3x plus 1 isolated by itself. So the square root of 3x plus 1 equals 1 plus the square root of x plus 4. Okay, so we've isolated, so now we'll square both sides. Okay, when we square the left side, we end up with 3x plus 1. And let's think about what happens when we square the right side. If I had 1 plus just x squared, that would be 1 plus x times 1 plus x. And if I do that multiplying through, I'll get 1 times 1, so I'll get 1 squared, plus x, so plus 2x plus x squared. So now think of that x as this whole radical here. So I'm going to end up with 1 plus 2 root x plus 4 plus x plus 4, because the root of x plus 4 times the root of x plus 4 gives me x plus 4. So let's clean up the right side. So that gives us x plus 5 plus 2 root x plus 4. And on the right, we still have 3x plus 1. This is where we need to repeat. We still have a radical in the equation, this root x plus 4. So let's leave that term by itself on the right side, and let's subtract x and subtract 5 from both sides. So we will end up with now 2x minus 4 equals 2 root x plus 4. So we isolate the radical, square both sides. Okay, so when we square, this time when we square the right side, it's the easier one. Remember that you need to square this coefficient as well as squaring the radical. So we end up with 4 times x plus 4 when we square the right. And on the left, we're going to get 4x squared minus 8x times 2, so minus 16x plus 16. And now let's multiply through the right side here. So we'll have 4x squared minus 16x plus 16 equals 4x plus 16. All right, so let's bring everything, now we have a nice quadratic, so let's bring everything to the left side of the equal sign so that it's equal to 0. So if we subtract 4x, we'll have a minus 20x. We've got 4x squared minus 20x, and we'll subtract 16, so that's that. So now we have a quadratic equal to 0, Let me scroll down a bit to give myself some space. Let's common factor the left side here. So we have 4x times x minus 5 equals 0. So we have 4x equals 0 or x minus 5 equals 0. So when we solve for this, we get x equals 0. And when we solve this one, we get x equals 5. So we have two proposed solutions. So let's test each of them in the original equation. So we have to go back up to the original equation. So if I test this one, I have 3 times 0 plus 1, and it's all under a radical sign, minus 0 plus 4 equals 1. So that gives me the square root of 1 minus the square root of 4 equals 1. So that's 1 minus 2 equals 1, which is not true, so not a solution. Or we could call it an extraneous solution. And let's test the x equals 5. So we get the square root of 3 times 5 plus 1 minus the square root of 5 plus 4 equals 1. So we get the square root of 16 minus the square root of 9 equals 1, and 4 minus 3 equals 1. So there's our solution. So 5 is the solution. So lots of steps to remember here, but they basically boil down to, and I'm just going to scroll back to the earlier page here, isolate the radical, square both sides, solve for x or simplify. But you may need to repeat the whole process if there's still a radical. And then your final step is to test your solutions. And as you could see with the examples that we did, sometimes some of them will be eliminated. And that's it for this lesson.